All right, welcome to class, everybody. Thank you for braving the snow. It's kind of intense out there. So our lesson today is section 5.8, but I also wanted to just kind of give you guys a heads up that our midterm and unit 2 test is coming up. So this week we'll have lessons for the rest of this week. On Monday, there's no school because of President's Day, I think. Some Monday holiday, that means you don't have to come to school. So no class on Monday, and then Tuesday is a homework day, just like normal. And then Wednesday and Thursday we'll have lessons. And then on Friday, I will do a review of all of the unit 2 stuff that we've learned so far. So just kind of like how we did last time, where you'll ask any questions you have on the study guide, and I'll get the study guide to you guys next week. So we'll do that on Friday. And then if you would like to take your test on that Friday, you're welcome to, or you can use all of spring break, which is the following week, to study for it and take it on the Monday or Tuesday when we get back from spring break. So you can kind of choose whether or not you want to get it out of the way before spring break happens, or if you want to have more time to study and take it when you get back from spring break. Any questions about tests or anything? Yeah.
Sorry, what days did you say it was open after spring break?
For 2 days, Monday and Tuesday. Yeah, I don't know what the actual days of the month are, but whatever those days are. Any other questions? Okay, awesome. So let's go ahead and get started on section 5.8. So section 5.8 is about using factoring to solve equations. So to kind of start our discussion about this, let's remind ourselves what a solution is. So when we're looking for a solution to an equation, we're looking for something that makes the equation true. You know, like if you replace the variables with these numbers, it makes the equations true. So if we had an equation like this one, where we have 3 variables, that means that we'll have 3 parts to our solution. Kind of like when we had 2 variables, you'd have ordered pairs. In this case, we'll have ordered triples. And what are some values for X, Y, and Z that would make that equation true? Okay, all of them are 0. Okay. Yep, that would work. Because if you have X is 0, Y is 0, Z is 0, if you multiply them all together, that would definitely equal 0. Are there any other solutions? Okay, so if I do 1, 1, and negative 1, 1 times 1 is 1. 1 times negative 1 would give us negative 1, so that wouldn't actually equal 0. But maybe if I change this to a 0, that would work. And technically you could have anything here, right? You could have like 12 and 37 and 0 or anything like that. So you could have anything in a 0. Are there any other possibilities? Yeah.
X, Y, or Z, and then go to 0, and
Perfect. Yep. So if I had X is 0, it wouldn't really matter what Y and Z were. If Y was 0, so I could have maybe 1, 0, and a million. It doesn't really matter what the other numbers are, as long as at least one of them is 0, right? Are there any numbers that, or any triples you could do where none of them are 0, but when you multiply them, they equal 0? Or do you have to have a 0 in order for the product to equal 0? Yep, for multiplication, yes, because like even if you did say like 2 times a half, you know, because those like seem like they're kind of opposites of each other, they don't equal 0, they equal 1. And so if you have things that are multiplied together and they equal 0, what that tells you is that one of those things has to be 0. Possibly you could have all of them equal 0, but at least one thing has to be 0. So this is called the 0 property of multiplication, and it's basically what you guys just described, which is if you have a bunch of things that are multiplied together and the result or the product is 0, then at least one of these factors or the things that are multiplied together has to equal 0. And that's the property we're going to be using in our lesson today to help us solve equations like this. Because we've been working a lot with polynomials, and now we're putting polynomials in equations. So remember, an equation is a math sentence, and all math sentences have the structure of expression, relationship, and then another expression. So, like you could have 2 plus 3 is the expression equals 5. That would be an example of a math sentence. And we've been working a lot with polynomials, which are types of expressions. But so far, we haven't had them in equations yet. Like they've just been single polynomials, and we've learned how to add them, multiply them, divide. Like we've learned how to do a lot of different things. But we've basically only been dealing with the expression of them. Now we're setting them up in equations where you have this polynomial is equal to something, in this case 0. And the way that we solve this equation or find solutions to it is we get the polynomial into factored form. So to get this into factored form, this is a trinomial. So I'll use my trinomial trick. And x squared times -8 is -8x squared. And what are two things that multiply to -8x squared and add to -2x? Yeah. Perfect. Yep, -4x and -2x. So we'd have x squared minus 4x. Oops, sorry, plus 2. I didn't mean to say minus. Plus 2x minus 8 equals 0. Then I'd split this into two groups. The first one has an x in common, so I'd get x minus 4. The second one has a 2 in common, so I'd get x minus 4 there as well. Factor out that common x minus 4, and I get x plus 2. And this is the factored version of this polynomial. So these two, they mean the same amount, but this is the factored version. And this is a much more useful version when we're trying to solve the equation, because if I have two things multiplied together to equal 0, by the 0 property of multiplication, one of those two things has to be 0. So one of my solutions is going to say, well, what if x minus 4 is 0? What would x be? Yep, x would have to be positive 4. And if I take x equals positive 4, you can see that this is a solution because 4 minus 4 is 0. 4 plus 2 is 6. So I get 0 times 6 equals 0, which is a true statement. And technically, it doesn't even matter what this term is, because if this is 0, whatever this is, when you multiply it by 0, it will equal 0. So that's one of my solutions. But I also have another solution, because it's possible that maybe this is the term that equals 0. And what would that solution be? -2. Whoops, equals -2. So these are my two solutions. And again, I could see that this makes the equation true, because -2 minus 4 is -6. And -6 times -2 plus 2, that's 0. -6 times 0 does equal 0. And so usually I don't even go back and plug them back in. I just know if it makes one of the factors 0, then it doesn't even matter what the other ones end up being, because it will make the equation true, as long as you have things that are multiplied together to equal 0. Now, it's really important that you make sure that it equals 0, because the 0 property of multiplication only works for zeros. Like if this was an 8 or something like that, there's if you have two things multiplied together, one of the things doesn't necessarily have to be 8, right? Because you could go 2 times 4 is 8. And so the only time that this works is if it's equal to 0. So let's do another example of this. On this one, we have the polynomial equal to 0. And it's a trinomial, so I can multiply my first and last terms together. And that gives me, I want to say 196 x squared, I think. Someone want to check me on your calculator? Yeah, okay. So I need to think of what are two things that multiply to 196 and add to -35. So 196 is a perfect square, and I think the square root of it is 13. Oh, 14? Okay, yeah. So 14 times 14 is 196. But 14 plus 14 doesn't equal -35. So let's see. So 14 can be split up into 2 and 7. So 196 equals 2 times 7 times 2 times 7. So maybe let's try 28 and 7. Because 28x and 7x. If we made those both negative, that would work. So those are two things that multiply to 196 and add to negative 35. So I'll do 4x squared minus 28x minus 7x plus 49 equals 0. Split it into two groups. My first group has a 4x in common, which leaves me with x minus 7. My second one has a negative 1 in commons, and I get 7x minus, or sorry, no, my bad. Has a negative 7 in common, which leaves x minus 7. That equals 0. And so my factored form is x minus 7 times 4x minus 7. So this is the factored version of the polynomial they gave me. To figure out what the solutions are, I need to say, well, if I have something times something else equals 0, one of those two things has to be 0. So I'm going to start off by saying, okay, well, what if it's this one that's 0? Well, if x minus 7 equals 0, that means that x equals 7. And that would be a solution because 7 minus 7 is 0, and 0 times whatever this is will equal 0. Then I do the same thing with this one. I say, okay, well, what if this one is the term that's 0, or the factor that's 0? So I'd say 4x minus 7 equals 0. If I add 7 to both sides, I get 4x equals 7. Divide by 4 and you get 7/4. And on this one, if I took this and plug this back in, 7/4 minus 7 would give you some negative number. But when I put in 7/4 here, 4 times 7/4 will be 7. 7 minus 7 is 0. So whatever that is, multiplied by 0 will equal 0. And so this is a solution, and this is a solution. Any questions on that? Yeah. On your homework, there'll be 2 spots, and you'll fill in the 2 spots with the 2 solutions. Yeah, and we'll talk about when we get to the word problems. There's some word problems where you'll get a negative answer, but you're like a negative number doesn't make sense in the context of it, in which case you just ignore that solution. All right, so on some of your homework problems, like question 5, oh, Alexa had a question. No, Alexa, I'll have easy numbers on the test. Yeah, they won't be that big. Okay, so on some of them, you'll have something that looks like this. And if you have an equation where it doesn't equal 0, then the way that you handle it is you make it equal 0. So in this case, when we have 300a equals 100a squared, don't start factoring until the equation equals 0. So to do that, I'll subtract 300 from both sides, which tells me that 0 equals 100a squared minus 300a. Now that it equals 0, I can get this into factored form, and I'll have 2 things that are multiplied together that equal 0, and then I can make each of those things equal 0. So in this case, both of the terms have a 100 and an a in common. So I'll factor that out, which gives me a minus 3. That equals 0. So here I have 2 things that are multiplied together. And if they equal 0, one of these 2 things has to be 0. So 100a, if that equals 0, what does a have to be? 0. So a equals 0 is a solution because 100 times 0 minus 3 would equal 0. And then for the other factor, what would a need to be to make this factor equal 0? 3. So my 2 solutions would be a equals 0 and a equals 3. Is everybody good with that? So main point of this one is that if it doesn't equal 0, you need to make it equal 0 by moving everything to one side of the equation.
And then where'd you go for that step? Sorry.
So once I made it all equal 0, then I just factored this. And the way I factored it, because these 2 had a 100 in common and an a in common, I pulled out the 100a, and that left me with this.
Okay.
And this couldn't be factored any further, so then I was done. Yeah. All right, so I'm gonna go through some more homework examples. So if you want to, you can follow along with me. But let's do a check-in on a scale of 1 to 5. How are you guys feeling about this concept? Okay, awesome. All right, so the next one I want to do is question 3, because question 3 involves fractions. So on this problem, we have 2/7 y squared minus 7/2 equals 0. So this is good that it's already starting off equal to 0 because that means I don't have to move anything to the other side. And you know how like when we've been working with polynomials, how I said, if you have fractions, you just kind of have to deal with them. You can't get rid of them. The reason why we couldn't get rid of them is because we were dealing with an expression, not an entire equation. Like you were just dealing with like, easy example, like you're dealing with 2 plus 3, not an equation, 2 plus 3 equals 5. If you have an equation, you could add 4 to both of these and it would still keep the equation consistent. But if you don't have this part, you can't just randomly add something or multiply something to it. So the only time you can multiply to get rid of fractions is if it's in an equation. Well, for the first time, since we've been working with polynomials, we now have an equation, which means we can multiply by 14 to get rid of these fractions. So I'm going to go ahead and do that because I prefer not to work with fractions when it's possible. So I'm going to multiply both sides of the equation by 14. And 14 divided by 7 is 2. 2 times 2y squared is 4y squared. 14 divided by 2 is 7 times negative 7 gives me negative 49. And 0 times 14 is just 0. So this is much easier to work with and way easier to factor than the original equation was. So how could I factor that expression? Yeah. Yep, it's a difference of squares. And so 4y squared is the same thing as 2y squared. So I'm going to do 2y minus 7 because that's the square root of 49. And then 2y plus 7 by my difference of squares formula. Is everyone good with that? So hopefully by now you've got this at least semi-memorized because you've used it on so many homework assignments. But this is the main one, the main special case I want you guys to memorize for the test because you won't have a note card. So this is important to memorize the difference of squares. Once we get it into factored form, then we say, okay, well, either this has to be 0 or the other factor has to be 0. So I'll say 2y minus 7 equals 0. Add the 7, you get 2y equals 7. Divide by 2, and you get y equals 7/2. That's one solution. The other solution is if the other factor equals 0. So if I subtract 7 there, I get 2y equals negative 7. Divide by 2. I get y equals negative 7/2. And so those two would be my solutions to this equation. Any questions on that? Okay. All right, so on question 6, and this is also true on question 8, they're giving you the polynomial in factored form, but in order to find the solutions, you need to be able to have the factors equal to 0. And so if you were to just subtract this stuff over, you would end up with something like 2a plus 1 times a plus 1 minus a plus 4 times a plus 13 equals 0. And this is not factored form because you have stuff subtract other stuff. And yes, you do have factors within those terms, but the overall structure is not things that are multiplied together. So what? Yep, exactly. Yep, so you basically what you do to solve this type of a problem is you FOIL out all of the stuff that they've put in factored form. So like you'd say 2 times a is 2a squared, 2 times 1 is 2a, 1 times a is a, 1 times 1 is 1. That would be equal to a times a, which is a squared, a times 13, which is 13a, 4 times a, which is 4a, and 4 times 13, which is 52, I think. I could be wrong on that. But basically you would get it all expanded out into a polynomial, and then you would subtract one of the polynomials over, and then you'd have some polynomial equals 0. And you could combine all the like terms because you have like all of these a's that can be combined. You also have a couple a squareds. So you would essentially expand them out into expanded form for polynomials and then subtract it so it equals 0 and factor that result. So I'm not going to go through that whole process because we've done a lot of examples of the factoring so far. But basically you need to expand it so you can combine the like terms. And that would be the same case on this one. So you would do t plus 2 times itself twice, FOIL that out.
You still have to move everything over though, right?
Yeah,
Move everything
you have to
over,
have it
that's
equal
the
0.
only way you can
Yeah.
get the like term, right?
Yep. Yeah. And I would, if it were me, I would expand it and FOIL it first and then move everything over. Because if you subtract it over, you'll have a negative in there. And like, you don't want to like accidentally forget to FOIL the negative. So I would FOIL everything out first and then move everything over and combine the like terms to make it equal 0. You could do it either way, but I think it would be easier to do it that way. So question 6 and question 8 are like that, where you have to FOIL them out and then combine like terms and then refactor it. On question 9, this one is one where you're going to have 3 solutions. So if we look at this equation, we have t cubed. Oh, I'm just going to actually do x's because t's look like plus signs to me. So I'll do x cubed plus 4x squared minus x minus 4 equals 0. So this one's nice because it's already equal to 0, but I need to get this side factored. So what would I do to get that into factored form? Yeah. Yep, because there's 4 terms, I can try out factoring by grouping to see if that works. So the first group has an x squared in common, which leaves me with x plus 4. The second group, it looks like, has a negative in common, which I can write as -1, which also gives me x plus 4. So it looks like factoring by grouping is going to work. I can factor out the common x plus 4s, and I'm left with x squared minus 1 equals 0. And is that fully factored? No, because I've got like this part's factored, but this one can be factored further because that's a difference of squares. So I can use my difference of squares formula and write this as x minus 1, x plus 1, because x squared is a perfect square, 1 is a perfect square, and so you can take the square root of each of them. And now that's fully factored. And if I look at each factor and say, well, all 3 of these multiplied together has to equal 0. So if this one is the one that equals 0, then x has to be -4. If this is the one that equals 0, then x has to be 1. And if this is the one that equals 0, then x has to be -1.
And that first term, x plus 4, was that x minus 1?
The x plus 4 came from this when we did factoring by grouping.
I'm just saying, what if
Oh.
they are, what if the first set that you factored
Is the same?
Same, do you square it at the end as the answer?
Nope, it would essentially be like 2 things that gave you the same answer. That's a good question because in more advanced algebra, they actually have a word for that, where if you get the same answer from multiple factors, they'll say that that answer has a multiplicity of 2. So like if this was x minus 1 and this was x minus 1, your solution would be x equals 1 because 1 is the thing that makes that equal 0. But the answer x equals 1 would have multiplicity 2 because there were 2 factors that created that. We won't get into that in this class, but there is a distinction for that. Yep. Yeah, because it's kind of like when we were back here and we were listing out solutions here. It's kind of like you could say that a solution is 0, 0, 1, where 2 of the variables are the same. Okay. So that's question 9. Do you guys have any questions on how to do it if you have a bigger polynomial? The overall strategy is kind of the same for all of these. It's just different, applying it to different problems. the overall strategy is set the thing equal to 0, get it into factored form, and then set each of the factors equal to 0 to find your solutions. Fourth, yeah. Oh, yeah, on this one, because it's an equation, you can just multiply to get rid of the denominators. So, because like you can get rid of fractions by multiplying if the fractions are in an equation. If they're not in an equation, you have to deal with them. But like in this case, I would multiply by 9 because that will make the entire equation way easier to solve. Okay, the other one I wanted to go over real quick was question 12. So on question 12, it says, let f of x equal x squared plus 2x, and let g of x equal 2x plus 25. And they want you to find all the values for the variable x for which f of x equals g of x. So basically what they're asking for is when they say find all the values for the variable x for which this is true, they're basically asking you for a solution to this equation. Well, this equation isn't very easy to solve when it's just f of x and g of x. But if you replace what f of x is equal to and what g of x is equal to, then you get the equation x squared plus 2x equals 2x plus 25. Because f of x was this stuff, g of x was this stuff. And then you can find a solution to this using the method we talked about today. So my first step would be to make it equal 0. So I'll subtract 2x and 25 from this side. And when I do that, that cancels out to 0. And 2x minus 2x cancels out. And I'm left with x squared minus 25. And then that's a difference of squares. So you could factor that. It's equal to 0. You'd find what each factor is equal to. Or like what would make each factor equal 0. So I won't go through and fully finish that, but I just wanted to kind of explain what the question's asking. The last one I wanted to go over was question 14. This is one of the word problems, and you have a couple word problems, and I can help you with them if you get stuck on them. But I want you to try it on your own. But this one, in my opinion, was the hardest one. So I want to kind of talk through how we do this one. So as with all word problems, you want to go through and write down what they gave to you, like the information you're given, and write equations or math sentences that represent those statements. So in this case, it says the dimensions of a rectangular photograph are even consecutive integers, and the area of the photograph is 48 square inches. The thing that we're looking for is the lengths of each side. So just to kind of visualize this, I have a rectangular photograph, and the things I want to find are the lengths of the sides. So I'm going to call one of the sides W and one of the sides L. I'm going to have W be the short side and L be the long side. So width and length is kind of where I was going with that, but if you want to do X and Y, that's totally fine too. So if we look at the information we're given, we know the dimensions of the photograph are even consecutive integers, and we also know the area of the photograph is 48 square inches. So let's start with the area. And how do we calculate the area of a rectangle? Yep, length times width. So in this case, I know that L times W equals 48 because I'm using L to represent the length, W to represent the width. Okay, so that takes care of this piece of information. Now I need to use this information that they're even consecutive integers. Yeah. It won't change the equation because it's very similar. So I'll explain where the equation comes from. So consecutive integers means like 5 and 6 or 8 and 9 or 100 and 101. Consecutive integers are basically numbers that are next to each other. So consecutive even integers would be like 22 and 24 or 100 and 102 or 2 and 4. Does that make sense? So they're separated by 2 numbers. So in your case, if you have odd consecutive integers, yours are also going to be separated by 2 numbers, but yours will be like 3 and 5 or 11 and 13 or something like that. So the way that I write this equation is I say, okay, well, I don't know what even integers they are. I know they're consecutive, meaning they're next to each other, but I don't know which ones they are. But I decided that L was going to be the long side of my rectangle. And so if they're even consecutive integers, I know that L is going to be whatever even number W is plus another 2. Does that make sense? And like, I don't know what options they have, but if they had just said consecutive integers, then you would add 1 because consecutive integers are like 8 and 9 or 12 and 13. So I don't know if they were all even or odd. Does anyone have just consecutive integers on theirs? If they're all even and odd, this will be the equation for everybody. Because even and odds are separated by 2 units. But if they were just consecutive integers, then you do +1. Okay, so those 2 equations represent all of the information that I was given, and I'm asked to figure out what L and W are. So essentially what we have here is a system of equations, but you can't use elimination to eliminate them because this L and W are multiplied together, not added. But you can still use substitution because if L equals this stuff, then you can replace that stuff for L. So I would write this out as W plus 2 times W equals 48. I took this stuff that equals L and substituted it in for L. When I multiplied this by W, I end up with W squared plus 2W equals 48. And I can solve that equation by subtracting 48, which gives me W squared plus 2W minus 48 equals 0. And then I can factor this and then set each factor equal to 0 with the stuff we talked about today. Yep, because it's a trinomial. And I think that's the case on all of your word problems. You should end up with a trinomial. But on most of the word problems, it will start off with something like this, and then you'll factor this out. And actually, let me finish this one because you need 2 parts to the answer. So when you factor this out, I think if I remember right from last class, I think it's +8 and -6. Yeah. So this is what you get when you factor this out. I didn't show you guys all the steps, but your numbers will be different anyway. So when you get it to this step, your solutions are going to be W equals -8 and W equals 6. Now remember, W is representing the width of the photograph. And so if you think about it, this answer might be mathematically correct, but it makes no sense in the context of the word problem because you can't have a photograph with a side length of -8 inches. Like distances are measured in positive numbers. And so we would just ignore that solution and this would be the width of the photograph. So that will be the width of the photograph. And then I need to figure out what L is. And so I could do this in 2 ways. I could either do 6 plus 2 because that would tell me what the length is, or I could say what times 6 equals 48. And in either case, you're going to get the answer 8. And so that would be the other part of the equation. Any questions on that? Okay. All right, so I think those are all of the examples I want to go over. If you guys have any other questions, that'd be helpful. Let me know. The last, I think, 3 questions are all word problems. So if you want to start on those, in case you feel like you might need my help with them, you can do that. But they'll be kind of similar to this, where you'll take the information that's given and create some type of equation like this, and then you'll factor that equation to end up with your solutions.